Okay, we're going to talk about how metamorphic rocks form. What's interesting about metamorphic rocks is that they are actually made from rocks that already exist. So, sedimentary rocks are made from sediment. Igneous rocks are made from melted rocks cooling off, but metamorphic rocks are made from a rock that gets changed into a metamorphic rock. So let's get started. Well, first of all, if you are looking at a rock and wondering if this is a metamorphic rock, if it has these funny looking bands inside, it's probably a metamorphic rock. They just look like they've been squished together. Now there's a reason for that. Metamorphic rocks are the unlucky rocks of the world because they got to their current state after being squeezed by intense heat and pressure. Now instead of having to write all of that down in your notes, usually all you need is something shorter, formed by changing other rocks with heat and pressure. In fact, if we look at the word metamorphism, we see that it comes from the word morph, which means to be transformed or changed. To morph is to change. The mighty Morphin Power Rangers. Morph means to change. So metamorphic rocks are previously formed rocks that have been transformed by exposure to heat and or pressure. Now the pressure comes from above. Imagine you have a mountain on top of you that will really press down really hard. And the heat comes from below. It comes from, the earth, the center of the earth is very hot. Now metamorphic rocks are rocks that haven't melted. So if the rocks end up too far down, they're just going to melt and become igneous rocks next time. But in this case, they are not quite hot enough to melt. Moving on. Now, influencing factors. So, we've already discussed two influencing factors that can transform pre-existing rocks, like igneous or sedimentary, into metamorphic rocks, which are heat and pressure. How it works. Pressure from the mass above, heat from below. Makes these rocks change. Let me keep reading. As you can imagine, it takes very intense heat and pressure to make rock change its form. In fact, the heat needed to make this change often comes from magma, which is the extreme heat you likely associate with volcanoes. Now we're going to go through the three different ways that metamorphic rocks end up forming. Okay, so what happens? The first one is recrystallization. Now, there are different metamorphic processes that are responsible for the changes that we see in these rocks. Recrystallization is the most common and defined as the metamorphic process by which the crystals are packed together, creating a new crystal structure. Recrystallization requires a lot of heat and pressure, and the process changes the mineral's shape and size, yet the basic composition remains the same. So if it's made of carbon, it'll still be made of carbon when you're done, but the heat and pressure will change it from, let's say, coal into a diamond. Big difference. So in our notes, instead of writing all of that down, the minerals get so hot, the atoms are able to slowly make new crystals. Now, an example. I'll read the example while you write down. Limestone, which happens to be made of the shells of marine creatures, the shells that you pick up on the beach, you pile them up high enough, bury them, they become limestone. Well, limestone, with enough heat and pressure, becomes marble. So, for example, limestone can go through the process of recrystallization to turn into marble. Limestone contains many calcite crystals that come from the shells of marine creatures that were broken down and compacted into sedimentary rock. So we're starting with a sedimentary rock. Then, that limestone is buried and subjected to intense forces. The microscopic crystals pack together and slowly morph into larger crystals of calcite that we find in marble. The same marble you might use as a countertop in your kitchen. So here's a limestone quarry. Limestone's not particularly useful. We can use it to build a building and it'll last hundreds of years. But marble is something that we used for things, and these things have lasted thousands and thousands of years. We have marble statues from the Roman Empire thousands of years ago. What you're seeing in this picture are marble countertops that have been made at a plant. These are very expensive countertops. So that is recrystallization. The next one is chemical changes. The chemically active fluids that circulate around a newly forming rock introduce different ions which cause new and different mineral crystals to grow. So not only is there heat and pressure and recrystallization going on, but there are chemical changes that can change what the rock is made of. So sometimes metamorphic rocks are made of something kind of new. Lastly, metamorphic process, the last one, is contact metamorphism. When large amounts of magma move into an area, they heat up the surrounding rock and cause them to change. This is called contact metamorphism. So if we see in the picture here, we have a magma chamber. We have magma moving into an area. Well, all that really hot magma is going to melt some of the rock that it touches, but some of it is not going to quite melt. What's interesting is when you look at rock layers like this, you can see that the rock closest to the intruding magma has been changed by this contact metamorphism. Magma heats and nearly melts the surrounding rock. Now, just a note before I finish, it's a great idea when you see a diagram like this to add it to your notes. And I'm going to let you go ahead and try to make a diagram for contact metamorphism. What you end up with is a magma chamber that's feeding up to a volcano, but all the surrounding rock, all the nearby rock, winds up being changed. So that's it for metamorphic rocks. Thank you.